We now move to operator overloading. But before starting with that, you'll have to know that all the Python variables like strings, lists, dictionaries are all classes. We could take a simple example on the strings. Let's do a help of string. You see here, this is actually the string class, which is used in Python. Here we have some methods defined, as you could see. So strings are actually classes. Same with lists. If we print out list, you see you have something like that. Dict. There we go. If we have two strings, say string 1, and we call it A, B, C, and then we have another string, string 2, we call it X, Y, Z. Let's print out string 1 plus string 2. So we see how we combine this by simply doing what we just did here. Now if we define some other variables, say variable A, we'll call it 3, and then variable B, we'll call it 4. Print this out. We have A plus B. You see that in Python, although we're dealing with different kinds of variables, we see that for the same addition operator, we are able to treat these two operations differently. Now let's modify this slightly. Suppose we have this call instead. So we have string 1 add string 2. Let's run that. You see that we have the same output we had when we just did the string 1 plus string 2. Let's come back to the string help. Let's search for add. Okay, now there we go. We see that this string class actually has this add method, and this add method is defined such that in it we have the current object, so we see a self plus the value we pass in, and that's why plus the object we pass in, and that's why when we pass in the string object, we actually have the string 1 plus string 2, just like what we had done here. Now this actually happens to be what we call operator overloading. Thanks to operator overloading, we are able to, for example, put in this plus here, and then automatically Python calls this method for you and is able to join this too. And then if we're working with a list, you see it's going to be similar. It's going to join the two lists. If we're working with just these numbers, you see that it adds it up. We could modify this. Say for example, let's print if the two are equal. We see it's false, they are not the same. Let's modify this. We use the equal operator. You see it's not the same. You could search for equal here. So there we go. So if this object is equal to this other object, we have that. Now let's take this off. We see how we could use simple operators like this, and then these operators could be converted into your corresponding methods in the Python classes. Now coming back to our smiley class, let's define our equal method. So we could define the equal method here. See, we have the object itself, and then we have another object. We should call it the SM or smiley, let's say SM object. SM object. There we go. We return self.isSmile equals SM object.isSmile. So right here we actually have two objects. We have this current object that is the self, which is represented by the self. We have this object. We check if isSmile is the same as the other object isSmile. If they are the same, then we're supposing that the two smileys are the same. So for now, let's run this. There's an error here. Take this off. Note that when defining this operators, we need to have the double underscores before and also after. And this method names aren't just some names we just guessing. They actually in the Python documentation. For equals is this. For addition, as we've seen, is this. For subtraction is sub. Anyway, let's do this. Yeah, sub. Let's copy that. And then for multiplication is mul. For division, we have true div. Let's put that. True div. And many others. So you could check on the documentation to see the exact method names we're gonna use. So coming back to this, we have this equal, that's equal. Then we've decided to say that two smileys are the same if the isSmile attributes are the same. So run this, it's fine. We'll define happy and we'll define that. So here again, let's now call in the equal method. So here we have sad dot equal, which takes in happy. Run that. See, it's false. They are not the same. Let's modify this. We say they're actually the same. Not equal. It's actually not equal. So let's not do that. Let's have that same. It's okay. And then let's not equal. Take this off. Run that. Run. And now let's modify this here. We have not equal. Run. Okay, but not equal is supposed to be different. So let's put that. Run again. And there we go. We have not equal, which is true. Let's take this off. Not equal is true. So it means that sad and happy and not equal. Now, what's interesting about operator overloading is that instead of doing this, we could simply say sad. We'll do that. And we still have the same response. So let's say instead of having this, let's print this out. So we see that instead of having to put this out like this, all we need to do is just now do this. So let's run that. Now let's come back to this here and then comment this back. We'll see what we get now. See, we have the same answer. Let's modify this and say equal. You see now it says false. So this means we have the power to modify what our smiley thinks is a different smiley from itself. So the fact that we could modify this means if we want to say, for example, that for the equal, if we want to say, for example, that for the two smileys to be equal or for the two smileys to not be equal, we could specify that this is equal. So this could be equal and we have, so let's add this. So to say that they are not equal, this could be equal and the face colors could be different. So let's just copy this, copy that. Now we just have face color. So if the face color is different, it's gonna be different. Run this now. You see that in this case it's false, and that's because the face color is different. Let's comment this. We still have the false. Now let's take this to be different. We have true. Take this. We have true still. If we modify this, we have or. And then we suppose that if they have this, that's if their face colors are the same, we set that to true. We say this is at true. So the point we're trying to make here is we could simply use this kind of operators, and then based on the class definitions, Python can automatically come up with some results. Let's consider again the object happy of the class smiley. To call on the set, or rather the head area method here, we could have happy.head area, and then it gives us a head area for that smiley. Obviously we're getting the default values. We could say radius equals say 2. There we go, we have a different value. Now we could actually call this class as if it were a function, and to do that we make use of the call operator overloader. So we have def call, we have that. Now here we shall return simply the head area. So we call on the head area method, and that's fine. Let's run this. We'll see how this works now. So here we let's print this out. We print this out, print this. Now we have happy. Now this actually is our object. We shall just simply call that. And what goes on here is once we call this object here as a function, it's gonna use or be as if we're making a call on this method right here. So let's run, and there we go, we have the same answer. If we take this off, let's say we return 2, take that off, see, that's it. So that's the call operator overloader.